Let's talk about function overloading in C++. So what is function overloading? Function overloading allows us to create two functions, completely different functions with the same name. So what does this mean? Let's take a look at an example. So you might want to have a function called average that averages two numbers, and a function with the same name that averages three numbers. So how would this work in code? So here's some code for it, right? We have our function prototypes here, one that takes two doubles and one that takes three doubles, right? They're both called average and they both return a double, right? In main, we call them with two numbers and with three numbers, right? And here are the definitions, and they are pretty much as you expect. There's one average here that takes two doubles, averages them, and returns the value. Here's another one that takes three doubles, averages them, and returns them, right? So the question is, how does the compiler know when it gets to a function call, which one of these two definitions to use? And basically, the compiler uses the function signature to determine which function to go to, right? The function signatures consist of two things. The first one is the function name, such as average, right? The second thing is the parameter list. So these are the types and ordering and number of parameters, right? So this has two doubles, one after another. This one has three doubles. So the signatures of these two are different, even though the names are the same. The number of parameters is different, right? Um, so actually, it is a requirement in C++ to have that every function must have a different signature. Now, one interesting thing to note here is that the return type, the doubles here, are not part of the signature, right? So they are not used to um, when figuring out which definition to go to, right? So does this work fine? Yes, it works fine. So most of the time. So let's take a look at this, and we'll try it out in our IDE, and we'll paste this here. And the IDE has no problems with it. So let's run it, and you can see we can run it just fine, right? So let's actually go back and talk about what kind of problems this can create. So, is it possible for the compiler to get confused and not know which of two functions to use? Yes, it is definitely possible. So let's cook up an example, right? So here again, you have something called average. Now this time we have two definitions of average. Now this here they both have two parameters, right? Each one has two parameters, but the types are different. Right? The types, the first one has a double first, and then int first, and then the second one has an int first, and followed by a double, right? So, and they are defined here, a fairly normal definition. Now, when the compiler gets to average and it sees that you have passed in a 5 and a 15, it doesn't know which one to go to. Should it go to the first one or the second one? They both look equally good, right? So let's see what happens when we actually try this out. It would be interesting. Do you get a compile time error or do you get a runtime error? So we will go ahead. We will uh, go and use this example instead. So let's see what this happens. Let's run this. So it tries to compile it, and what happens is it does in fact get confused, and the message is call to overloaded function average is ambiguous. So you're calling it with average int. Now there are two of them, and it doesn't know which one to use. All right, so this is called ambiguous invocation, and this is exactly the message that you see.